In today's session, we'll talk about the bitwise operators. Bitwise operators, like they are very important in embedded system programming point of view. Okay, and the other operators and all everybody have seen, you understood it was all simple. And if you remember, logical operators I already discussed. In logical operators also, that time also I was talking about the AND operation, OR operations and all. In that case, in logical operators, you must have seen that I was using, if I am writing logical AND, I used the ampersand symbol twice. All right. So similarly for OR operation, I was using this OR. Okay, so that pipe symbol twice. And in logical operation, it is basically comparing two conditions. Two conditions it is. Suppose if it is a variable, if the variable, for example, I am having a variable x equal to 2. So the variable x is a non-zero value. Whenever it's a non-zero value, it is considering that as a true condition. So something is 0, it is just considering that as a false condition. I am just concluding that logical operators. Okay, so logical operators were comparing two conditions. That's it. But the bitwise operators is totally different. Even while we are writing the bitwise operator, for example, for AND, we will be using only single ampersand sign, or okay, or we will be using the single signs. That's very straightforward. And here we'll be using this negation symbol for the not operator. There we were using the exclamatory symbol, right? So I think that and all very straightforward things. And here we'll be focusing more on the bitwise AND, bitwise OR, and bitwise XOR. And apart from that, this right shift and left shift. I'm not very sure whether you people are already aware about it or whether you people done any example. If I'm asking, everybody will tell, yeah, of course, I know what is left shift and right shift. It is not only knowing, you should write the program. First of all, you work like with the paper and pen. So you see if I am shifting some binary data, how it is happening, what will be the new value. Okay. So what will be the corresponding hexadecimal value? That until you can test it quickly. Even if you don't know how to convert a decimal number to hexadecimal or binary. So for maybe for this example sample, you can use any online converters. Okay, so using that online converter, just try to verify whether the binary data what you got. Okay, so what is the corresponding decimal or hexadecimal number system? All the like the corresponding value, just test it online. I'll show you that. Okay. Maybe somebody is completely new to this, like especially in embedded programming or computers, they like to work with the binary data, but we like to work with the decimal data. So there should be a conversion. I will try to do one program how you will be converting only decimal to binary. So other things and all you can like work similarly. So the other programs and all you should write how you will be converting a decimal to octal number, decimal to hexadecimal. All right, so that you can try it. Maybe our primary aim of the session is to focus more on the bitwise operators and just to see what are the applications of this bitwise operators in embedded programming. Especially maybe the coming session onwards, I am actually working with the real target board. So in that target board, maybe as a beginner, we will keep the examples of LEDs. We will connect multiple LED. If you have around 16 LED, it's well and good that we can connect in a port. Okay, so one port, okay, we can connect it, or whatever LEDs you have, try to use that, and we will try to make different patterns. This pattern making and all straightforward, it's simple, but if you are already aware about the bitwise operators and all, that become more easy. And also try to see what you mean by the binary. Okay, so for every number, every decimal number system, I don't want to talk about the decimal numbers again and again here. We'll be talking always about the hexadecimal or the binary numbers or binary representation we will see. There you can actually apply the concept of like left shift and right shift and all. Alright, so out of this I am about to start with the shift operations, because shift operator, if it is clear, the other operators and all you can quickly grasp and you can quickly make some application. I don't want to teach you what you mean by AND. Okay, so everybody know what you mean by AND condition. Like I think that you studied in school days, right, in maths. And means the truth table you can write it and see 0 0 0 0 1 0 1 0 0. Okay, 1 1. If both inputs are 1, then only output will be 1. That's simple. And or means what? If any input is 1, output will be 1. Okay. 0 0 0 1 0 or 0 1 or 1 1. In these three cases, output will be 1. Either any single input or both inputs, if like if they are 1, then output will be 1. That's it. And bitwise XOR is very important, and maybe if you are not aware, I'm not sure whether you remember or not. Okay, so just to remember the bitwise XOR, I'll just tell you one statement. If you're able to remember, it's very clear. So bitwise XOR is an odd one detector. Odd numbers of one it will be detecting. What do you mean by that? If I am writing the truth table 0 0, no ones, right? So output is 0. 0 1. So that means to say there is 1 0. Number of ones is 1. That means 1 is an odd number. So output will be 1. Then again 1 0. Again there's an odd number of 1 over there. So again output will be 1. But for 1 1, 1 1 means two ones are there. 2 is an even number. So output will be 0. So XOR means odd number of odd one detector. Okay, odd one detector means if there is an odd number of ones, then output will be 1. That's it. I think this is very clear. If you are able to understand this, of course you can remember. And the shift operator, like by looking at the shift operator, we should understand that like where the point is actually. Okay, so where the tip is pointing. So like you should do that. So that side. Okay, so towards that side it is shifting. So here on this one on top you can see it is bitwise left shift. Why? Because the arrow is towards the left side of you, right? So it is bitwise shift left, and the other one is of course bitwise shift right. Okay, so I'll show one example. If I am shifting any number to left side, what is happening to that number? And if I am shifting any number to the right side, what is happening? I am talking about the value. Okay, so the value is getting increased or decreased. Okay, so there is one calculation, simple calculation. It's all straightforward. Yeah, so I think one program I will write for the shift operator. We will see that. Of course, I am telling everybody, I am requesting everybody should write parallelly with me. Okay, so don't wait. Okay, everything is get over, then only you will write the program. Don't wait till that time. So try to implement everything parallelly. You can like learn it in better way. Then. Yeah, let's move on to the ID. Yeah, so you can look at my screen. I already written this program. So let me explain it. It's very straightforward. But one thing I did it a little tricky. Maybe people are already aware. We discussed this thing in storage class. So what I would like to discuss. So at the beginning you can see I declare the header file stdio.h since I'm using like printf and scanf. I'm using scanf also. Okay, because I would like to ask the user to input any number. So all please be very clear. Okay, so listen carefully. Okay, so this session, I'll try to explain each and every basic thing through this program. Okay, right. So here you can see then one more header file I'm using stdint.h. Okay, stdin.h. We never used it before, right? So this header file I'm including. Okay. So now onwards, whenever I'm declaring any variable for embedded system, means embedded C program, I don't want to write it like a char or int or short like that. I don't want to write. If you want, you can write, of course, primitive data types you can directly use. So if you remember, whenever we were discussing the data type, I told you one thing. For example, if you're having an integer data or character data or float data, so the size of that data type, okay, or size of the variable, whatever you are declaring using that data type, always will be depend on the compiler. Okay, so if the compiler is 32-bit, I already told you one hint. So if the compiler is 32-bit and usually the integer size will be 32-bit. If the compiler is 16-bit, okay, so the hardware, okay, so then you will be able to see your integer size will be 16-bit. So it is always compiler dependent. Okay. And in embedded programming, in C programming for the host machine, we don't want to think about all these things and all. So, but whenever we are writing the program for the target board, okay, all the time it will be different target board, okay, and maybe it can be 16-bit controller, 32-bit controller and all. One thing I have to clear or one thing I have to make sure that whatever variable I am declaring right now onwards, whatever variable I am declaring, I would like to fix their size. So for example, if I am declaring a variable num1, instead of writing simple integer, I can write int 32 underscore d, which is already type def. Type def is something, what I can say type def, maybe I'm not sure whether you are like already aware or something. Using type def keyword, I can alias. Okay, so I can give some other name to some variable. Okay, so maybe for structures and all. So we will be discussing that when we are doing structures. So far, you just understand that I haven't done anything here. This in std.in.h in that header file already it is defined that instead of writing simple integer, I can write the size of the integer. What I need. I need a variable called int 32 underscore d. So num1, which is a variable, okay, whose data type is integer. This integer is 32-bit. Okay, so 32-bit long in this program, throughout this program, which is already defined. All right. For example, I need an integer. So basically, 8-bit means what? 8-bit means it's a character only, right? So if I want a character, so I can write int 8 underscore t. Okay. Then if I want a variable, I can declare that variable. Are you getting what I'm talking? Yeah, I hope it's clear, right? If you need a 64-bit integer, of course it's possible. You just want to write int 16 underscore t, that variable. All right, so this is one thing I would like to show you. And now onwards, I'm telling for every variable declaration, we'll be using like that. Then we can ensure that, okay, how many bits are there for that particular data type. All right, so that we have done. Num1 is a simple integer that will be 32-bit long. Okay, all right, fine. Then after that, you can see I'm just asking the user enter a number. So let them enter a number. So that number I'm just storing in the variable called ampersand number, which I already declared here. No problem. So now what I like to do, the number which I am entering, usually I would like to enter the decimal number, or maybe you people are entering the decimal number. So what I like to do, the decimal numbers corresponding hexadecimal. Okay, hexadecimal number system, that is base 16 number system. Decimal means what? Like in school days we started. No? Decimal means we used to count 0, or maybe we started with 1, whatever it is, 1 2 3 till 10. Okay, so again it is repeating. In hexadecimal number system, the number system will be base 16. Decimal means base 10. Binary means base 2. Octal means octal, octa, like number system will be base 8. So similarly, hexadecimal number system will be 16. 16 means what? 16 means we will be having the number from 0 to 15. Okay, so what do you mean by 15? That means 10. Okay, so 0, 1, 2, 3, everything is same till 9. 10 will become A. Okay, so like the A, B. Okay, so 11 will be B. Like that we will be having till F. So 0 to F. That is what hexadecimal number system. I think it's very similar. Okay, maybe you people are even aware about it. All right. So if I want to means if I want to print the hexadecimal representation of the corresponding decimal number, what I can do here, I can use this format specifier %x. That's it. Okay. So here you will be asking why I am writing 0x. It's not mandatory you have to write 0x. So usually hexadecimal numbers will be written as 0x something. So 0x, one example I am telling, 0x8f. So 0x indicating that it's a hexadecimal number system. Usually for decimal we won't write anything. That's straightforward, we'll write the number 47. That's a decimal number. If it's a binary number, we can write 0b, then 1100 something. So that means it's a binary number. So I just want to write in that format. So you can see I am writing 0x, whatever you are writing here, as it is, it's coming in the console, right? So here you can see %x I am using. So instead of %x, the variables hexadecimal, okay, corresponding hexadecimal number will be coming over there. So here you can see, like suppose if I am entering a number, decimal number %d. Okay, so decimal number is the number which I entered. So here you can see I am using the variable num1, and whose hexadecimal representation is %x. The same number in decimal and hexadecimal I am printing in the single line. That's what the line number 23 is. All clear? So this is one new concept. Then std int, I think that's clear. Okay, I want to fix the size of the integer, whatever I am using. If you want 16-bit or if you want 64-bit, it is totally your wish. Okay, I fixed it to 32-bit. Okay, so irrespective of the compiler, it will be 32-bit always for me. So that's done. Then after that, you can see one more thing I would like to show you. If you remember, whenever you are using like scanf, right? So we were not able to see the output in the console. In the previous programs and all, I was using only printf function. So I was able to see the output, the like maybe the variable status and all, I was able to see it in the console. But maybe earlier also you face this problem. Whenever you are using scanf function, we were not able to see the output in the console. So what you did, you just went to the binary. So you went to the binary properties, right? So you just went to that location. So in Windows command prompt, okay. So we were able to run the program, nothing. So it will be asking any input if you want to give. So it will be writing in the console. So we were like giving some input. And if you remember that time I told you, if you want to hang the screen, what you are using? So you are using a getChar function. All remember? So what I had written in getChar function, while new line, right? So till the time, if I am not pressing enter, or till the time I am pressing the enter key, it was waiting. It was hanging for me. Okay. So that I already implemented. Okay. I was writing that here, if you remember. I was writing the program here, right? While one and getChar and all. So now what I did, I don't want to write every time the same program. So what I have done here, you can see I created one more file here, one more .c file, which I showed you already when we were discussing the external storage class. Okay, it's very straightforward. You can just right click and you can just add new, then source file, whatever name you like, you can give. So you can see I created one more source file here. Okay, so that source file name is user.c. Let it be. So here I would like to define one function. Okay, so this function is basically doing maybe the task. Okay, so which is hanging the screen. So that function is done here. Like I defined it here. All right. Okay, so here you can see the header file I included. Then I am just defining a simple function. Okay, so the content of the function all clear. So the function return type is void. Let it be. The function name is screen underscore hang. Some name I have given, not taking any argument. So here inside this function, I just written this line. Okay, so which previously we have written in other program. Press enter key to exit this application. Then here while getChar not equal to new line. Okay, so just hanged over there. It is in the waiting state. That's it. Then getChar. So which usually we used to write it in the main program. Now I don't want to write it in the main program because in every program I am going to write. I am going to repeat it. So what I did, I created this as a separate source file. I defined this within a function, a screen underscore hang. That's it. So now this .c file is a part of this program. Left shift, that's my like folder name. It's a part of it. Now in the main.c program, I would like to use this function. If I want to use this in the main.c program, first of all, I have to write the prototype here. Okay, I have to declare the function. So whenever I am declaring the function, I will use this keyword called extern because it's telling the compiler that there is a function called screen underscore hang, but it's not a part of this main program. Somewhere else, some other source file, it is defined. So the compiler understood the instruction, it will go and search in other files and where it is defined. From there, the compiler will be able to fetch it. That's it. All right, so I think that's clear. Yeah, so whenever I'm using extern keyword, I don't have any problem. If I'm not using extern keyword, it will be throwing the error. And if you want to declare the prototypes and all, always try to do this before the int main. Okay, so I think all clear, right? So here you can see that after doing all this printing, I will tell you what is its printing. So after doing all this printf statement, I would like to call this function. Here I am calling the function. So prototype always try to declare before the main function. Calling of the function should happen where you are supposed to call the function. That means where you are supposed to write those lines or write those program. Okay, so basically I would like to write this program maybe to hang the screen maybe at the end of this main function. So here only I will be calling the screen hang function, screen underscore hang. So all this instruction it will be able to execute. It will be able to fetch it over there. Alright, so that is helping me to hang the screen. External storage class is clear. So that application we implemented here. Alright. Yeah, so then after that, let's see which shift I'm doing. I'm doing the left shift. Okay. So if you want, you can write a comment here. I'm doing the left shift. Okay. So left shift means what? Left side it is shifting. So whenever you are shifting something to the left side, always the value of that variable will be increasing. Okay, so for example, I will tell you 0, no value, 10 rupees value, right? So again, I shifted one to the left side. So 100 rupees. Again, I am shifting 1000 rupees. So whenever any value you are shifting to the left side, the value is going to increase. The logic is very simple. The same thing I would like to show you here. Suppose if you are having a variable and if I am writing the variable, okay, so whatever the given variable, if I am writing like this, num1, the variable which I am giving decimal value, num1 left shift by 1. Okay, so then the value I am printing in both decimal and hexadecimal. I already told you why. I just want to see the corresponding hexadecimal representation. So here you can see percentage %d I written num1 left shift 1, and for percentage %x also the same variable. If you want, you can copy this to a new variable and you can print it. I don't want to do all this. So num1 left shift 1. Okay, so it is already giving the output here itself. Num1 will be the value which is left shifted by 1. So whatever the content, so in the decimal format and hexadecimal format I am displaying. Okay, so I already told you whenever there is a number shifting to the left side, the value is getting increased. And how it is getting increased? So if you are shifting it once, okay, so here you can see I'm shifting only one position. This is the position what you are shifting. Okay, syntax is like that, the value, then shift, then for how many position you are shifting. So I am shifting only one time. So if I am shifting one time, the decimal value actually getting the value of the variable is actually getting doubled. Okay, so similarly if I am shifting twice, the value will be multiplied by 4. So shifting 3 times, the value is getting multiplied by 8 times, like that. So like that, the value is getting increased if you are shifting to the left side. So from here only it is clear that if you are shifting to the right side, of course it will be division. Opposite of multiplication, it is division. Okay, we'll see that. We'll see that as a separate program. So I think it's clear for all. Okay. Maybe one confusion will be there why I would like to display that in the same number left shift one. I am just displaying that in the decimal and hexadecimal format just to understand. That's it. Okay. If you don't want to use it, then just go and like use any online converters. Okay, from decimal to hexadecimal. For binary, we don't have any format specifier. So far, we don't have. Otherwise, I could have write percentage %b, but we can't use it. All right. So that's the reason hexadecimal I can. Oh, okay. So hexadecimal representation I can print it. Now let me run this program. I already built this program. So here you have to see, you have to go to the properties, and from properties you will be able to open this file, location. Alright, so left shift.exe. So let me enter any number. I am just entering the number 47. Let it be. Okay, so you can see decimal number 47, hexadecimal representation is 0x. So you understood, right? Usually it will be coming only 2f only. Okay, but I would like to display this as the hexadecimal number just for the better readability. So if you remember, I written already 0x. So that 0x by default it's coming. It was actually the output of the line 0x then percentage x. Okay, so percentage x is actually replaced by 2f. Percentage x, it is, that means 47 hexadecimal was 2f. That is coming as it is. And before that I simply written on 0x, so that is coming. That's it. And here you will be able to see that if I am shifting one time, 47 is actually getting multiplied two times. So the decimal value become 94 and the corresponding hexadecimal I am getting. Okay, so like that it is happening for every cases, decimal and hexadecimal, right? But if you want to understand this in very detail, you have to work with the binary data. Okay, so then only it's giving better clarity, right? I hope it's clear. So if you are shifting to 2 times or 4 times, okay, so 3 times, whatever it is. So accordingly, it's getting multiplied. So the conclusion is that whenever we are doing left shift, the value of the variable is getting doubled, or the value of the variable is getting increased. Okay, so that is one conclusion. I hope that's clear, and maybe this program is clear. I'm just concluding again. I was using stdint.h here. Then I was using external storage class here. The purpose I think all clear. Then I was just implementing the left shift operator. Then one more additional thing which I showed you about the hexadecimal representation of the number. That is also your choice, your wish. So that was about the left shift operator. Okay, so left shift operation. Let me show you an example how this operation will happen. That we just try to work with the paper. Okay, so using the paper and pen, try to draw that diagram. So then it will be giving better clarity. The program I think is clear. The program even I will upload. So like you can have a detailed look. So you can look at my screen. So this is an online like a calculator I'm using. If I want to convert the decimal to binary, I can just enter the decimal number here 10. So if I want to calculate, means if I want to convert that to binary, you'll be able to see the binary number is 1010. That's it. Yeah. Now if you are looking, I think my screen is visible. If you are looking at here, so this is my binary number corresponding to the decimal data 10. The binary is 1010. Suppose if I am doing 10, then left shift by 1. Okay, so one position I am shifting to the left side. So what will happen? This 0 will come here. Okay, so whatever the content that will go here, like that it should happen. So if this 0 is coming, it is empty here. So this is 0, then this is 1, and this is 0, and this is 1. Okay, so this will be the new data, the updated one, which is left shifted. So it means to say here if it is empty, then I can make it 0. So what is this value basically? Let me use the calculator again and I'll show you. Yeah, so you can see this is what the value which I got right now, 1010. Then 0 got added, right? Because it was empty here. So in the empty space, I just added the 0. Like that only left shift will happen. So which is the vacant space. So there will be appending 0. So the data become 10100. So the original data was 10. I did the left shifting by 1. Okay. So in the calculator where I added this number, so 10100, this is what I got right now. I am doing right now binary to decimal conversion. So the binary is 10100. So the corresponding decimal number is 20. So as per the like our theory, it's correct, right? So whenever I am doing one position left shifting, it is actually multiplied by 2. So 10 was the original decimal number. Now it become 20. That's it. Okay, so try to use this online converters if you are not completely clear about the binary, decimal, hexadecimal and all. Okay. So similarly, if I want to get the hexadecimal corresponding, So the original number was 10, right? So now the number decimal number become 20. So let me get the hexadecimal representation. Okay, so whatever the number you like, 10100. So the corresponding hexadecimal number is 14. Okay, so hexadecimal, till till 15 it's there, right? So hex number is displayed like that. All right. So for example, if I'm having a decimal number, so decimal number hexadecimal is what I already told you, A. Okay, so 11 means B, like that. 15 means F. So what do you mean by 16 then? Okay. So 15 is F, everybody know. Then what is 16? So 16 is like the hexadecimal become 10. Okay. All right. So I think that's clear for all. Right. So I'm just ending the session. So we just did only the left shifting. Okay. So we were doing only the left shifting. So try to implement this in paper or work like any medium. Okay. So then you try to write the program. All right. Yeah, I hope all clear about it. With this, with this note, I'm ending the session. Maybe like we will do one more. Okay, so we'll do quickly one more program we will do, or maybe the same program we'll just shift for the, we will alter for the right shift. So in right shift, I told already the reverse is happening. So here if it is multiplication, so there the division will happen. So let's write that program now. Okay, so yeah, that's it. Thank you all. Bye.